Today's lesson is going to cover the distributive property, and our goal for today is going to be I can rewrite algebraic expressions by combining like terms and applying the distributive property. So what we're doing in this lesson is building upon our combining like terms lesson, but at this point we're going to start incorporating the distributive property. So our I can statement is similar, but we've just added on applying the distributive property. So let's jump in. First and foremost, let's get a quick definition of the distributive property. So what the distributive property says is that multiplying a number by a group of numbers added or subtracted together is the same as doing each multiplication separately. And I'll show you what that means in a minute. Also, please remember that I do want you to write down everything that I give you in your notebook. So this first sheet you should get written in your notebook for your title, and the goal should be in there. And then also this quick definition of the distributive property. So I'll give you a minute to copy that down. Or if you'd like, you can pause the video here. So next, let's take a look at the foldable that you'll get to put in your notebook. So the outside gives us the many different forms of the distributive property that we might see, and the inside will give us some problems that I'll have you work on through this process. But let's go back to the beginning first. So as the definition stated, it says that multiplying a number by a group of numbers added or subtracted together is the same as doing each multiplication separately. So if I'm looking at my first one here, I have A times the quantity B plus C. And as we can see, by doing the distributive property, that gives us A times B plus A times C. Now when I write these out, what I like to do is draw arrows using or from the number that's multiplied on the outside to each number that it will be multiplied by on the inside. So in this case, we have A times B and A times C. Zoom in here quick. Alright, that's better. So what this tells me is A times B, so I do that like they have here, and that's still going to be added to because this is really a positive 1 in front of this C. So A times C would be on this side. So I'd end up with A times B plus A times C. The same idea would be carried out down here. So I would draw in my arrows from the term that's on the outside to each term that's on the inside. So I do A times B, which you can see here, and then A times negative C, which would give me negative A times C. So really giving me A times B minus A times C. Now sometimes you might also see a term added in the beginning first, and really there's no term here that's to be distributed. But that's not really true because there is a positive 1 in front of here. So we're really multiplying each of these terms inside of here by a positive 1. So my A would stay, and since I'm doing a positive 1 times a B, I would have 1B, or just B, and 1 times C, which would give me 1C, or just C. And my final expression would be A plus B plus C. Now another one we might see is where this is a negative and it doesn't look like there's a coefficient here. But remember, just like this top part here, there's a negative 1. So we'd be distributing a negative 1 to each of these terms inside of the parentheses. Now just like with combining like terms, the coefficient is going to take whatever sign is in front of it. So in this case, this is a 1 here, but since this is a minus, we're going to consider this a negative 1. And I shouldn't say minus, I should say a subtraction sign. So this 1 is going to take that on, and we're going to multiply each term inside by a negative 1. So my A would stay. Then I do negative 1 times B, which would give me a negative 1B, or a minus b here, subtracting a b, and the same thing with the c. A negative 1 times a positive 1 is a negative, so I'd have a negative c, and giving my final expression of a minus b minus c. Now sometimes they may also change the term that's inside of the parentheses. So in this case we just have 2 and we changed it to a subtraction sign. Remember, this is a positive 1 in front of the parenthesis there, and that's going to take on the sign in front of it, and we'll draw our arrows in to each term inside the parentheses and carry out our distributive property here, or our multiplication. So we'd have a, that'll stay. 1 times b would give me plus b. A positive 1 times a negative 1 would give me a negative 1, so I'd end up with a negative c, or negative 1c, leaving my final expression as a plus b minus c. And last but not least here, we'll look at one other form that this could take, and draw in my arrows. Remember, there's a 1 there. So a stays. I do negative 1 times a b, so that would give me negative b, as we can see here in the final expression. And then we have a negative 1 times a negative 1c. Well, if we remember, a negative times a negative is a positive, so that would give me a positive c, leaving my final expression as a minus b plus c. And like I've mentioned before, your integer operations, they don't go away. So you'll need to keep those in mind when you're doing the distributive property as well. Now, one other thing that I would like to mention also is that on all of these, the term that's multiplied is on the left-hand side. So as we can see here on the left. Now, these can definitely be on the right-hand side as well, but the process is the same. You still multiply the term outside by everything that's inside, or I should say everything inside by what's outside. And I'll show you an example of that real quick using this same one here. So let's look at this first one that we have. We have a times b plus c. Well, I can also rewrite this as b plus c times a. And I'll put a dot in there just to signify that it's multiplied on that side. Now this looks completely different from this because this a is on this side, but you're doing the same thing. You're still distributing this a to each of the terms that are inside of the parentheses. So this would still give me a times b plus a times c. It's the same thing. So just because this variable or this number or whatever's on the outside here is on the right-hand side doesn't mean that it's a different process. You're still doing the distributive property. It just looks a little different. So we could even do that with something like, let's take this one here, a minus the quantity b plus c. So if I did a, let's see, which one is it? I could say a plus b plus c times negative 1 on this side. I should show multiplication, so I'll just put that in parentheses real quick, because otherwise it looks like a minus 1. So this is still going to be the same process. I'm multiplying, and I'm going to draw my arrows, my negative 1 by each of the terms. So although it's not on the left-hand side, it's the same idea. So I'd have a minus b minus c. As you can see, it came out the same way as this one here. Because I distributed a negative 1 to each one of these, there's a positive 1 is the coefficient of each of those, so a positive times a negative gives me a negative still, leaving these negative b and negative c. So don't be alarmed when the term that's outside is on the right hand side. You're still doing the multiplication. Same process, same idea there. Let's get into some real examples then. So if you open up your foldable here for your notebook, you can see that there are a few examples. And we'll go through a couple together, and then what I'd like you to do is try some on your own. And then I'll show the correct answer sheet at the end, and you can compare yours to that to see if you're doing this right. So let's take a peek at what we're going to be doing. So what I want you to do first is look at the expression and then draw your arrows in to each from the number that's multiplied outside to each of the terms inside, so that we don't forget any of our steps here. Or I should say multiplying anything that's inside, because sometimes what I've seen is that you'll do the first one, but you'll forget to do the second or third or fourth or however many things you're multiplying inside. So we've drawn in our arrows. Now we need to look here at this one. What number or numbers should be distributed? Well, in this case, -2 should be distributed to each of those. And when we distribute, we're multiplying. So our next step is to distribute. So we have -2 times a positive 1x. That would give me a -2x. And then a -2 times a -3. Remember, the number or variable that you have will take the sign that's in front of it. So don't make the mistake of doing -2 times a +3, because really this is a -3 that we're multiplying by here. So pay close attention to that. That's just like the combining like terms that we looked at. So -2 times -3 is a +6. And here's where combining like terms comes back in. So I'm going to separate everything that I have. Remember, like terms have the same variables and the same exponents, and how we write them in the end, that order doesn't matter. So we have a -2x and we have a +6. Neither of those have the same variables or exponents, so our final expression would be -2x plus 6. So that's our first one there. Now let's jump down to this one where it says 2 minus the quantity -x plus 5. And these other ones that I'm skipping over, I'll have you try those on your own here in a minute, but we'll go through a couple examples together. Now this one is kind of tricky. If we look here, we have a minus sign and there's no number here, or it looks like there's no number here. But really, there's a -1 in front of that. And what I would do on these types of problems is draw in that 1 or -1 to just get that in your mind that there is a number there that I need to multiply by, because chances are if you don't write that in, you'll probably forget to do the distributive property there. So once again, let's draw in our arrows. Now this time, this 2 is just out here in front as another term. We'll come back to that in a little bit. But we're just distributing this -1 to each of the terms inside of the parentheses. And I highly stress drawing your arrows. It helps you remember that you need to multiply everything inside by the number that's outside. And the number that we're distributing here is -1. And I'm going to go ahead and rewrite this expression after I distribute it, so the 2 will stay. If I do a -1 times a -1x, remember I'm multiplying the coefficients here, so -1 times -1 would be positive, so plus x, and then -1 times a +5 would be a -5. So that's our expression after we've distributed, but we still need to combine like terms. So I'm going to separate everything, so I have an x by itself, and that's a positive x. And then I have a +2 and a -5. So as I can see, this x is just going to be by itself. So I'll put x, and then I have a +2 plus a -5. So if I'm looking at that, I have more negatives. I'm going to add 2 positives to it, so that's going to bring me to a -3. So I'd write minus 3. So that brings me to my final answer here, which is x minus 3. So that's just another example where the number that you're multiplying is a negative 1. So don't forget that. To write that in there, and you're multiplying everything by a negative 1. Remember, the number takes the sign that's in front of it. So let's do one that gets a little bit longer here. Let's do 3 minus 2 times the quantity x plus 1 plus the quantity 5x minus 4. So in this case, I have two numbers that I need to distribute. One of them is going to be this negative 2. So I'm going to draw my arrows. Remember, this 3 is just out here. It's just part of the expression, so we'll include that later. And then here's another spot where it looks like there isn't anything to distribute, but really there's a positive 1 here. And you might be thinking that's not going to do anything because you're just multiplying it by 1, but I still want you to recognize that you are doing the distributive property here. So if you recall at the top, the numbers to be distributed are negative 2 and a positive 1. I'm just going to put a slash between the two of them. So if I do the distributive property then, I'm going to do 3, because that's still there, negative 2 times a 1x. So I'm looking at the coefficient, there's a 1 there. Negative 2 times 1 would be a negative 2. So minus 2x. Negative 2 times a positive 1 would be a negative 2. And then 1 times a 5x, so 1 times 5, the coefficient you're multiplying by, that would just be plus 5x. And then 1 times a negative 4, remember this sign goes with this number, so 1 times negative 4 would be negative 4. So that's our expression after distributing. Now let's write down our terms. So it looks like I have x's that I can combine, so negative 2x and a 5x. And then I have a 3, and I could draw in my lines here, like we talked about with combining like terms. So I have a 3, positive 3, a negative 2, and a negative 4. And make sure I have all the terms, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So remember, we can combine these together. So a positive 5x and a negative 2x would give me a positive 3x because I have more positives here. And then I have a 3, a negative 2, and a negative 4. So a positive 3 minus 2 would be 1. And then 1 minus 4 would be a negative 3. So my final expression here would be 3x minus 3. And let's go ahead and do one where we actually are distributing a variable. Yes, you can distribute a variable as well as a number. So in this case, I see a negative 3x. Now I need to do two things here, and I'm just going to draw my arrows in for each of these. So I have a negative 3x I'll be distributing, as well as a negative 1. Don't let those sneak past. So draw in your arrows. Now the terms I'll be distributing are a negative 3x and a negative 1. Now when I do this, I need to multiply the coefficients as well as the x's together. Now that might seem confusing, but I'll show you what we're doing here. So if I do the coefficients here, I'd have negative 3 times negative 1, or I'm sorry, a positive 1, which would still be a negative 3. And then I have an x times an x. Now this gets into exponent rules. When we multiply something that has the same base, we add the exponents. So technically these are both to the first power. So if I did x to the first times x to the first, I'd add the ones, the powers, so 1 plus 1, and that gives me x squared. So my first term is negative 3x squared. Then I would have negative 3x times negative 4. Here I'd just be multiplying the coefficients and the x will come along. So negative 3 times negative 4 is a positive 12. And then the x as well, because we can't forget that. We have this plus 2. That just comes along for the ride. And then I distribute this negative 1 here. So negative 1 times 5 is negative 5. And negative 1 times a negative 1x would be a positive x. So that's my expression before combining like terms. So if you come up here, it shows that we've decided what to distribute. We did the distributive property. Now let's combine like terms. Remember, same exponents, same variables, and the order at the end that you write it in doesn't matter. Drawing my lines here as well. So I have a negative 3x squared, a positive 12x, I have a positive 1x, and I have a 2, a positive 2, and a negative 5. So I have nothing that I need to do with this x squared. There's not anything else I can add to it, so that just goes first, or I will write it first in this case. 12x plus 1x would be 13x. And then a positive 2 minus 5 would give me a negative 3. Or I can think of it as I have negative $5, or I owe someone $5, I pay them $2 back, I still owe them $3, so minus 3. And that would be our final answer for that expression. So with the 6 problems that remain, what I want you to do is to try those, do each part here, what number should be distributed, distribute, combine like terms, and find the final answer. So what I do right now is pause the video, finish those 6 up, and then compare them to the answer sheet that I'll put up here in a couple seconds. And actually do try them so you get a little bit of practice with this before you fix your entry slip or you do your weekly assignment this week. Okay, so what you should have done then is finished the 6 problems that were remaining, and what you can do here now is go through and check the ones that you did on your own. If you have questions, please ask me so I can help you understand what's happening in each one of these problems, as the distributive property will come up in a lot of things that we'll do in the future. So make sure you have a good grasp of what's going on here. If you want to pause the video here to check your answers, that would be a great idea. And if you can remember all the way back to the beginning of our video, we were doing the distributive property today, and our goal was I can rewrite algebraic expressions by combining like terms and applying the distributive property. We're specifically focusing on applying the distributive property in today's lesson. Remember, we are expanding on our I can statement from last week. So hopefully after you've watched this video, you have a better understanding of the distributive property. And if you have any questions, please ask me, as I'm happy to help. And on one last note, please make sure that your graphic organizer, or your foldable, as I should say, goes into your notebook. It'll be a good help in the future, so make sure that you just tape down these portions here on your notebook page so that this is easily accessed for future reference. And once again, if you have any questions, please ask.